conditional probability. We already have done conditional probability yesterday when we were doing the Titanic problem. That was conditional probability because the condition might be that you are female, so what's your chance of survival? Conditional probability most of the time is going to be done, or for what we're going to be doing, will be done from a chart. So that you would do like we did yesterday. So for example, here, if we find the probability that you're a female given that you survived, okay? Now, the order that those two things are in matters. So this is the probability that you're female given that you survived. So the bottom number is the total number that you're looking at. What is the total that you should look at? It is not 447. It is 499. Because that is the number of people that survived. So this is not looking at your chances of surviving if you're female, but the chances that if you survived that you were female. Okay? So we know the person survived. What's the chances that they're female? So as you're watching everybody get off of the lifeboats, you're noting, oh, there's a lot more females than there are males, right? So if we just had a list of the survivors. So whenever you see that notation, the P and then the parentheses, something, line, something else, whatever comes last, that's what you know. That's what you're choosing out of. That's the number that goes on the bottom of the fraction. Okay? So there were 499 people who survived. So out of the 499 people who survived, how many of those were female? 324. Okay, most of the time you will go through this and find these probabilities from the table. So just go through it logically. Whatever you see after that line, that's what you're given. The total number for that goes on the bottom, and then on the top is your probability that out of those that survived that you were female, so that you'll put that number on top. So there are some times whenever we may need to find conditional probability using a rule instead of just looking at a table, because maybe we don't have a table, maybe we were given pieces of information. So I have three rules right here. Probability of A times probability of B divided by probability of B. Then there's the probability of A times the probability of B divided by the probability of A. And then Katie says the rule that should be probability of A and B over the probability of B. Okay, so we've got to decide which one of these rules here is right. Okay, so what I want us to do to kind of figure out which rule is correct, let's kind of work backwards on that last problem. All right, so female is your A, survived is your B, because it said probability of A given B. Oh, sorry. So the first rule that you see there was probability of A times probability of B over probability of B. So the probability of A means that the probability that someone is female. So the total number of females is 447 over everybody, right? Because we're talking about out of everybody here. And we're not talking about out of everybody for the whole thing, but probability of A means just probability that you're female out of everybody. So that would be out of 13, 16. And then it'd be the probability of B, and that's the probability that you survived, and that's also out of everybody. So probability of survival was 499 out of 1316. divided by the, let's see, probability of B. So probability of B was 490, sorry guys, 499 out of 1316. That would be that first rule, the rule that Jared argues is correct. So if I figure this out, let's use the calculator for this. So let's see how much you can do. So if you use the calculator there, 447 over 1316. They do. I was hoping somebody would see this. These two right here, they're going to cancel because they're the same on top and bottom. So it's 447 over 1316, which is 0.33966. 324 divided by 499 is 0.649. So these are not the same. So on that third slide there, this one does not work. Will the second rule work? Is Alicia right? Can you tell before we try plugging numbers? It's not going to work because what's going to happen with P of A and P of A? They're going to cancel out, which really means you're just talking about probability that you survived, which is not the same as the probability that you're female given that you survived. So it's not this one either, which should lead us to believe that it has to be the last one. Let's go back up and just see how that works, because we just did this from the table, right? We didn't use any specific rule. Well, this doesn't work very well. Let me erase here. So if we take the probability of A and B, so the probability you're a female and you survived. How many females survived? 324. And that's out of everybody, out of 1316. And then it's over probability of B. So what's the probability that someone survived? How many people survived? 499 out of everybody, out of 1316. So whenever you do this, you're going to have 324 over 1316. Dividing fractions is easy as pie. Flip the second and multiply. So over 1316 divided by 499. Your 1316s cancel, so you'll get this answer up here. Now, I'm not suggesting you should use this formula. It is harder than just looking at the table. I just want us to kind of see that that formula does work for these situations, because we're getting ready to see some problems where we're just given percentages. We're not given an actual table with numbers of people in it. So let's look at the problems that you may see. Most of the problems you'll see for conditional probability will have a table. And so you need to decide how many people fit this category, what is it out of for those, just like we were doing with the Titanic problem yesterday. For these, it's going to be different. So in a lottery drawing, 40% of the balls left in the drawing are red balls. 25% of the balls left in the drawing are 25% of the balls left in the drawing are red and over 25. If the next ball drawn is red, what is the chance that it is also over 25? Okay, so let's just think about what the question's asking us for here, because this is confusing to me, I think. So if you read that last sentence, that's usually your question, what it's looking for. So if the next ball drawn is red, so what are we given? What do we know is true about this ball? It's red, right? So we are given that it is red. What is the chance that it is also over 25? So we are looking for the probability, well, the probability that something is, or that one of the balls is greater than 25, given that it is red. We know, it tells us if the next ball drawn is red. So that's the condition. That is what we know about. We know for sure it's red, right? So if it is red, that's our condition. That goes last. Okay, so your condition always goes last. The the thing that you know. So like on this problem that we did here, it was probability of female given that they survived. So we knew they survived. That was the group we were looking out of, and then we're looking for the ones that are female survivors. So whatever is the thing that you know or the condition that you're looking at, that is the one that's going to go last, okay, after the line. So in this case, we would have to do the probability that the ball is greater than 25 and red out of the probability that the ball was red. Make this. Give me a little more room because I'm out of room. So the formula for this is probability of A, which is whatever comes first, or probability of A and B. A is what comes first, B is what's second, over the probability of B. So in this case, our probability that the ball is greater than 25 and red, what is that? Another probability we need is the probability that the ball is red. So you can give me either one. Which one? Somebody know? Say it again. 25 over 40 for this, because it tells us 25% of the balls are red and over 25. They meet both of those conditions. And then we know 40% of the balls left in the drawing are red. So if we know that it came from this 40%, I know that 25% of those are going to be, it's 25% of all of the balls left, right? But once I've narrowed it down to red, that's going to make that percentage larger. So for this, you would take 20, you can do it with the numbers or you can do it with the decimals, so 0.25 over 0.4, or you could do 25 over 40. Either one is fine. Typically, the answers are going to be given as decimals, but I don't think it matters which one you do, because you'll get 0.625, and I think you get the same thing if you do 25 over 40. So it doesn't really matter whether you use the percentages or whether you use the decimals. Okay, questions? All right, on these, you just need to use that formula because you don't have a table that you can look at to kind of reason through it. You're just going to use the formula. So let's look at number 2. This is, I think that I actually looked this up. This is like actual data. I can't remember for sure. I do know that Alaska does not have a lot of women that live there. So if you're having a hard time finding a man, you might need to go up to Alaska where there's not as much competition, ladies say. Not as many women live in Alaska as men. So I can't remember if I made this up or if I actually found numbers. I might have made it up, but there is some truth to it.
Why is that?
It's really cold. I think we do have some military bases up there that's probably gonna, it's not a huge population anyway, so if you do have some military bases up there, they're gonna be primarily male. That's gonna affect it. It's hard to live up there, so like, you know, yeah, like, and especially in some places. I mean, I'm sure if you're in like Anchorage, it's not that bad, but if you're like out in the far reaches of Alaska, I think that might be, you know, if somebody lives off the grid out alone, I feel like there's a better chance they're male than female. But yeah. Yeah. Yeah.
I would kind of like, I think it'd be a cool experience.
Okay, so we want to know, if you're a man in this Alaskan town, what is the probability that you are single? So what are we given? What do we know for this condition?
63% of them are men.
Okay? So, if the question says, if you are a man in this Alaskan town, what is the probability that you are single? So, when we're doing our probability, we're going to do, is it single given that you're a man, or a man given that you're single?
Assume that you're a man.
If you are a man, so that first part that says if you are, we're assuming that you are a man. We've chosen this person, we know that he is a man. So if you are a man, that means you're given that this person is a man. So that goes second. Whatever you're given goes second. And then single goes first. Okay? So according to the rule, we would take the probability that you're single and a man, and we would divide it by the probability of what you're given, the second thing, which is man. So probability, should have probably said male. That would have sounded more professional there. But so probability single and man over probability man, because these statistics that are given out of the entire population. So 63% of the residents are men, and 25% are single men. So this is not 25% of the men are single, but 25% of all of the residents are single men. So both of these statistics are out of everybody, not out of only males. We want to narrow this down where we only look at the males and see how many are single. All right? So, for this, what is the probability that someone randomly chosen from Alaska would be single and male? 25. I'll use percents this time just to let you know it does not matter whether you use the percent or decimal as long as you're the same on top and bottom. And what is the probability that someone just in general is male? 63. Okay, so if we do 25 divided by 63, 0.3968. So 39.68%. There, so about 40%. So even though 25% of the population are single males, if we know they're male, it's higher percentage. If you they scented markers. Okay. All right. So, premium tires make up 13% of the tires a company makes. About 27% of the tires that they make are for 20-plus inch wheels. About 8.3% of the tires they make are premium tires for 20-plus inch wheels. What is the probability that a premium tire is for a 20-plus inch wheel? Okay? So, we want to know what is the probability that a premium tire is for a 20-plus inch wheel. So, which one is it? Is it the probability that a tire is 20-plus, given that it's premium? Or is it the probability that it's a premium tire, given that it's 20-plus? Okay, it's the first one. What is the probability that a premium tire, so they're telling us it is a premium tire, right, is for a 20-plus inch wheel. So we're wanting to know the probability of a 20-plus inch wheel, given that we have a premium tire. Okay, so according to the rule, we'd have the probability that a tire is 20-plus and premium software writing over the probability of what? its premium. Okay? All right, so what is the probability that a tire is 20 plus and premium? What is it? 8.3. And then we got to put that over the probability that a tire is premium. $13. Okay? All right, so 8.3 divided by 13, 0.638. Or 63.8%. The idea being that if you're going to buy a premium tire, there might be a higher chance that you're driving something with fancy 20-plus inch wheels on it, right? They don't put huge wheels on cars quite as much as they used to, but they do not put big wheels. 20-plus might not be the best thing to say anymore because you don't see the huge wheels quite as much. But like over 18, if you go look at, somebody's cheapest that you can buy, 20-year-old Corolla or Civic or something down there in the parking lot, it probably does not have 20-plus inch wheels on it. If it doesn't, he should definitely put some on it. Whenever I was in high school, the ones that spin, they were really popular. The spinners, like the big wheels with the inside spin, so they stop and they look like they're still going. Yeah. Yeah. So, all right.